In this homework problem, we had a bunch of M&Ms, and we're looking at the color distribution, and we know that M&Ms come in brown, red, yellow, green, orange, or blue for this problem. Okay, and it asks, what's the chance that if we draw two M&Ms that we get them to both be the same color? Now, anytime you have something like this, I find it easiest to understand at a basic level if I kind of list out what all the possibilities are. You don't have to do this every time, but this might help you visualize what we're doing. So if I wanted to draw two M&Ms, I'm going to put over here on the left side, I'm going to put what I get on my first M&M, and my choices are brown, red, yellow, green, orange, blue. And across the top, I'm going to put my choices for my second M&M, brown, red, yellow, green, orange, or blue. And then we're going to look at the intersections here. So if I drew out a brown and a brown M&M, I'll write here brown and brown. Or I might draw a brown one first and then red. So that would be brown and red. Or I might draw brown first and then yellow. And let's do brown and yellow. And I keep going, like right here I could do red and brown. So red and brown. So you'll see there's a lot of different combinations I can get if I draw out two M&Ms and look at their color. And it turns out, so if you come down here, I went ahead and mapped out all of the possible choices to save time. And you'll notice there are 25 possible combinations, or possible color pairs, we'll call it that. Now remember, our problem said, what's the chances of getting two M&Ms that are the same color? Well, let's look on here to find pairs that have the same color. So I could get brown and brown, or I could get red and red, or I could get yellow and yellow, or green and green, or orange and orange, or blue and blue. Now I'm saying or here because doing blue and blue would satisfy my having two colors. Or I could do red and red, and that would also satisfy what I want. Or I could do yellow and yellow, and that would both be the same pair. So when I'm going through, I'm saying, well, this has to be brown and brown. Or I could get red and red. I'm being very particular about what words I use here. So to get two M&Ms of the same color, I can have brown and brown, or I can get red and red. Now, red and red is matched together. Or I could get yellow and yellow, or green and green, or orange and orange, or blue and blue. So now, to find the probability of two of the same color, I have to look at the probability of brown and brown, or red and red, or yellow and yellow, or green and green, or orange and orange, or blue and blue. Now, anytime you're doing probability, you need to remember that or means you're going to add, and means you're going to multiply. So when I go through, I'm going to do it in pairs. So this blue and blue, let's do that first. So for blue and blue, sorry, actually these are supposed to be brown, sorry. For brown and brown, the probability of the first brown is 0.25, and we said the bag's big enough that it won't affect the next bag or the next M&M. So the probability of the second M&M is 0.25. So I multiply here for that and, but for the or, I'm going to put a big plus. Now my next red one is going to be 0.3, and I want another red one, so I have to multiply at 0.3. And I'll do a plus. So we did red and red, so I'll do a plus now for the or. Now we want yellow and yellow. So yellow is going to be 0.15, and we times because it's an and. We need them both to happen together. Or, we put another plus. Green and green, let's see, green is 0.1 times 0.1. For that other or, let's do another plus. Let's see, orange and orange, so that's going to be 0.05 times 0.05. We did that one. Now plus for our last one, blue and blue of 0.15 times 0.15. Putting this into my calculator, if I did it correctly, because it is a long one, it looks like we should be at 0.21. So now that we did all that work, remembering and means multiply, or means add, we went through, we found out what are all of our possible combinations. They'll give us two of the same color, and then we found the probabilities for each of those combinations and added them all up, and I get to a final 0.21.